Thanks, Kelly. My name is Haley Oliver, and I'm a professor of food science and the director of the USAID Feed the Future Food Safety Innovation Lab at Purdue University. And I'm excited to be moderating this session on environmental controls for food safety managing outside the box. In this session, panelists will highlight novel strategies for identifying and managing outside pressures on clean food production facilities to improve food quality and certainly safety. We have a distinguished lineup of panelists, some of which are my mentors, at least historically, and I am proud to introduce each of them. This session will consist of 4 brief 15-minute presentations followed by a panel discussion. I'd encourage you to submit questions at any time using the questions box in the GoToWebinar control panel. With that, it's my pleasure to introduce our first panelist, Dr. John Butts. Dr. Butts has served as a primary technical role at Land of Frost for over 40 years. Land of Frost is a privately held company and the third largest sliced meat manufacturing lunch meat brand in the US. In 2010, Dr. Butts founded Food Safety by Design, LLC, to help producers of high-risk products learn how to prevent and manage food safety risks. Food Safety by Design incorporates root cause identification and development of preventive methodology for risk identification and management. And near and dear to my heart is one of my mentors. Over to you, John.
Thank you very much, Haley, for that very warm introduction. I appreciate. We're going to talk today about Zone 4 seek and destroy process. What we want to do is get a feel for how we control these various parts of our pathogen control program. So next slide, please. Next slide, please. So the strength of controls required as people, equipment, and materials move from Zone 3 to Zone 4 is directly proportional to the outside risk or the likelihood of transfer occurring. This is why we measure in non-exposed product areas, or Zone 4. Hurdles to entry into the exposed product area must be designed and deployed based on the risk of passage from Zone 4 to Zone 3. If you do not measure, you do not know what it is nor when it changes. Both of those are very critical, as we have found out the hard way. One thing we have learned the hard way is once a pathogen gets inside the Zone 3 area, the food processing area, the initial rinsing process during sanitation will facilitate and enable harborage. When I learned HACCP, sampling was a CCP2. Most of you probably never heard of that. Today, it is a critical factor in preventive controls. As we know, it is not a CCP because it does not present direct control. So here are some fundamental basic pathogen control concepts. Zone 4 sites are indicator sites. We place them in pathways of movement. We know movement is required to transfer the organism from Zone 4 to the product. Once inside the exposed product area, samples on the pathways of movement are no longer indicator sites. They become verification sites. These sites measure the establishment's microbiological process control ability to prevent product contamination. Zone 3 sites not in a pathway of movement are what we call Zone 3 indicator sites. We want the positives we find to be from indicator sites. Verification site positives mean we have a program failure. Firefighting commences. It's all hands on deck. Indicator sites, however, give us a chance before there's a food safety failure. So positives are celebrated. Next slide, please. We have learned that there are three microbiological process control pillars. First, we must eliminate or learn how to manage harborage sites, the fundamental concept of seek and destroy. Once a pathogen or its indicator is removed, we must control the movement. This prevents the organism from taking up residency. If we suspect harborage in a growth niche, an intervention is applied. We are now in the preventive phase of pathogen control. The next phase is predictive phase. This occurs once predictive indicators are deployed that identify the loss of control. Zone 4 sampling is a classic example of a process preventive control. Next slide. For preventive controls, data is required. So the environment within the exposed product area is controlled to minimize outgrowth. Multiple barriers or hurdles create a tortuous pathway to minimize the possibility of entry by a pathogenic organism from outside the exposed product area. My question to each of you is, do you have or have you experienced that tortuous pathway? I do not consider a foot bath with some sanitizer a tortuous pathway. Now, Joe here may take opposition to that statement in principle. We've argued about this from time to time. His argument will be the soles have to be clean. My position is a sole scrubber will both clean and sanitize. We know either of these methods must be and frankly can be effectively managed, but the key here is creating that tortuous pathway. Next slide, please. Here we created a sliced lunch meat plant. We did a greenfield in 06. I'm sorry, I jumped ahead. The first positives were at the employee entrance, days after we started production and started measuring. Zone 4 was a long controlled, dry quat laden pathway to the cafeteria, lockers, and gowning area, followed by an entry into the Zone 4 pack-off area, then through the sole scrubber and another gowning area, getting the employee into the RTE area. The processing or raw side of the plant, at the entrance, the employees went the other direction. So this plant was in a rural area. Raw meat is received and converted to cooked logs, then passed into the RTE area. Dry quat has been used on the floor in the RTE area since opening. The facility has yet to have its first Zone 1 positive. And the Zone 3s, we can do in the fingers of both hands. Next slide. Here's a plant in an urban area. We've really had no positives for years at the employee entrance. Raw meat processing area has a controlled exit through a long sole scrubber, again into a quat-laden gowning room. Gowning room exits to a common hallway where lockers and cafeteria are shared with RTE employees. The facility does not have contained footwear, and there is no sole scrubber at the Zone 4, Zone 3 entry. The data supports this situation. So this is where Zone 3 verification sites are extremely rare in this facility. The preventive controls are working. So this is an example of how to safely simplify while reducing cost and maintaining a high degree of microbiological control. Donning and doffing time is minimal. This is when the predictive phase of pathogen control brings the food safety culture into that internalization phase. Next slide, please. This is an example where we have a sliced lunch meat facility with raw boning capability. At the time this occurred, we were doing about 250,000 pounds of turkey a day in the boning operation. We had major RTE floor repair. This occurred in the mid-90s following extensive floor positives. Frankly, we just quit sampling for a while. It was that bad. Upon completion of the new floor positives started appearing in and around a non-controlled entrance from dry storage. We discovered the root cause to be a puddle in a trash pathway in the boning area at the far end of the plant. So the RTE trash receptacle was added to the RTE area, eliminating that pathway. Now, this was before we knew about dry quat. This was before we recognized the necessity of hygienic zoning. These are things that led us to the understanding the necessity. Now, several years ago in this facility, we had an influx of Listeria LS positives in the Zone 4 pack-off area. We found these to come from wooden pallets. Our supply chain management had changed prior to this happening. We ended up changing pallet suppliers and strengthened the hygienic zoning between Zone 4 and Zone 3. Again, this was a great payoff for the Zone 4 monitoring that we were doing. Next slide, please. My consulting business led me to a nut butter plant in an area where dust storms, I found out, were prevalent. The facility had product positive for salmonella. There was an area following the roaster where there was a window with a bird screen. Upwind, there were 5 high-intensity dairy operations within a few miles. Don't know exactly how far they were away, but they did exist. So, next slide, please. It was a clear, sunny day when I landed, then sunny as I entered nut butter land. Hark, I looked. There's a storm ahead. I hope I know how to turn on the windshield wipers in this rental car. Well, this is what the storm looked like once I got into it. It wasn't wet. Next slide. Look out, tumbleweed ahead. You can see one on the road and one flying through the air up to the right. Next slide. There's another one. It was about 4 feet tall. Now, there was no evidence or linkage established between the animal operation and product. The lack of preventive controls was clear enough. Now, the timing of this event occurred long before FDA presented the concept of preventive controls. Next slide. The consulting business also led me to a very large leafy green plant in Salinas Valley. A beautiful linear layout. We left the upstairs office area, walked down a long hallway that ran parallel to the length of the plant. As we entered the receiving area where field crates were being dumped into the flumes, we gowned up and got our gloves on. We were really protecting the product. We went through a foot bath. Then we exited directly into the hallway, no hurdles. Furthermore, there was separation between the first and second flume, but there was no hurdle to manage foot or vehicular transfer. These are examples of things that we've had to learn over the years to help us manage the entry of pathogens into the processing area. Next slide. So the pillars of control: eliminate residents. If you're at this stage and have not eliminated all your harborage sites, it's very important to prioritize your investigative efforts to find those harborage sites in the Zone 3 processing area. I would not typically chase Zone 4 positives at this point in time. Zone 4 transfer potential is reduced through control of entryways. Measure those entryways, then control the transfer or movement of the organism, then deploy process management techniques. Next slide. That's it. Thank you very much.
Thanks, John. Those pictures of tumbleweeds reminded me of home growing up in Wyoming. I don't believe we had any nut butter plants, so I'm going to assume it wasn't Wyoming, but still, I don't miss the wind, so I can appreciate that. But it's my pleasure to move on to our next speaker, Dr. Virginia Dybel. Dr. Dybel is the Chief Scientific Officer, for Dybel Laboratories. She has a PhD in microbiology and a minor in bacteriology from the University of Wisconsin-Madison. Virginia has 30+ years of experience delivering food safety services and working with the contract laboratory environment. Virginia is a certified consultant for the British Retail Consortium, the BRC, a lead instructor with the International HACCP Alliance, and a lead instructor for FDA Food Safety Preventive Controls for human foods. Virginia provides regulatory guidance, including assistance with responding to notice of intended enforcements, notice of suspensions for USDA regulated products, and 483s for FDA regulated products. Within this work, she has been a lead investigator in microbiological harbor site investigations, specializing in pathogens such as Listeria monocytogenes and Salmonella, along with cauliflowers, yeast, lactic acid bacteria, and spoilage organisms. Over to you, Virginia.
Great, thank you so much, Haley. And thank you all for being here this afternoon. It's my honor to talk with this panel, especially being sandwiched in between Joe and John, who have been with the industry for as long as I can remember and have shaped my my views and opinions. So today I'm going to be talking about when new equals risky, specifically as it relates to equipment onboarding. Next. For today's talk, the opinions that I'm going to express are exclusively mine. They are not reflected of any type of affiliation or financial interest. Next, please. Okay, so today I'm going to talk to you about two case studies. Case study number one is a plant that had a equipment that they onboarded, and this particular equipment was brand new. It was new to the plant, and it was constructed just for them. In the second case study, I'm going to outline equipment onboarding from another company, and this company purchased a piece of equipment. It was new to them, but it was a used piece of equipment. Okay, next, please. So the first thing to understand about equipment onboarding are the preparations that are needed, which can be fairly time-consuming in their planning. And so the preparations deal with the removal of existing equipment, if that is pertinent to the situation, the planning of any construction that is needed, especially because the construction would be in a ready-to-eat production area. The preparation of the equipment before installation, and then the actual equipment installation itself. And those are examples of 4 planning steps that should be conducted prior to having the equipment used in production. Okay, next, please. Okay, case 1. Next. So this is a photo of a company. This is the after photo, and they onboarded a fairly significant piece of equipment in their production, which is a spiral freezer. And this is the photo of the freezer after it was installed. What we're going to do now is talk through the steps of what it was to get the equipment to this particular stage. Okay, next, please. So the old freezer, they had a spiral freezer, and again, it was a significant piece of equipment in their production facility. The old freezer had a number of components to it that were problematic. One is that it was very old. the walls were fiberglass, but there was an insulation in between the inside wall and the outside wall. In addition, the inside had panels of stainless steel that were welded together, and the same was true of the floor in the spiral freezer. And then the floor sat right down on the second component that was troublesome for the plant. It was a concrete pad. And the issues were that the plant had a consistent and fairly significant Listeria monocytogenes harborage, and they identified the harborage in the freezer. They identified the harborage in the freezer walls where the welding of these stainless steel panels were affixed together. They noticed it in the, it was identified in the floor where there are holes in the stainless steel, and water would get on the concrete pad and geyser up into the freezer. The concrete was inaccessible. The concrete was not able to be sanitized, and it acted as a sponge to both the Listeria and to soils. The third component of this old freezer was that it had a trench drain that was immediately outside, and the trench drain would capture and exchange bacteria between the base, the concrete pad, and the trench drain. And the trench drain ran all the way along the entire production area. And so they couldn't contain the Listeria. Next, please. So what did they do? They removed the entire freezer, which was a considerable project. So what they did is they started by demolition, and they brought the outside in a front end loader to remove the structure. What the plant did, though, is that they had planned for traffic patterns, because they had to remove the panels, and they already knew that the panels could contain Listeria monocytogenes. So they had a containment program or plan where they contained the panels as they were being removed through the plant. Now, the removal process had to go through other production areas, so it was 100% hermetically sealed as it was moved out of the building. And the contractors were trained. The contractors were also managed by employees who monitored their actions throughout the entire process. Next, please. Then the removal of the concrete pad, which entailed jackhammering the concrete. As you can imagine, the concrete dust was significant, and the Listeria was heavily contained within the pad. And they managed the project by constructing a temporary wall, which is the black structure in the back. There's a production room immediately behind that temporary wall. They hermetically sealed that wall so that no dust could get in back of it. They also did they managed the removal of the concrete by containing it as it was removed from the production facility. And it was the same with the other structures in the freezer, wherein the traffic flow was highly managed by trained contractors, and they were overseen by the plant employees. Okay, next, please. So in this process, even though there was not necessarily something being brought into the plant per se, it was a process where there was a high degree of movement in and out of the plant. There was a high degree of movement of known contaminants throughout the plant, and there was a high degree of movement of many people. And so this plant was able to manage this process by planning and by hermetically sealing or building temporary walls of a containment area, and monitoring the traffic flow and thinking in advance of how to remove contaminated product from the facility. The other thing that they did was that they involved food safety experts in the design of the new spiral freezer. And so the interior of the freezer has solid panels. There's no welding. The freezer is, as you can see, is removed from the floor, enough so that you can see it, enough so that it can be cleaned, and it can be sanitized. And then it is not on a concrete pad whatsoever. It's an epoxy covered flooring. Okay, next, please. So in case number 2, next, we're going to talk about a equipment onboarding where another plant onboarded a piece of equipment, but this piece of equipment was used. It was new to the plant, but it was used in production at another facility. Next, please. So before I start with the case, I would like to have a segue and talk a little bit about the difference between terms that are commonly used and sometimes used interchangeably. And so the terms are harbored site versus a root cause. And the question here is there a difference between the two? And the response is, indeed there is. And so let's walk through the differences between harbored site versus root cause. When there are confirmed positive test results, if a plant decides to host an investigation, one of the things they're asking in that investigation is the cause of those positive results. Is it due to a harborage, an area in the plant that has a soil buildup and bacterial buildup, a place that's hard to see, hard to reach, hard to clean, a place that's sheltered from chemicals, and that's always exposed to water? That would be a harborage site, and that harborage site can linger in a plant for days, for months, and even years. Now, site, the next question is, how did it get there? What is the root cause? And root causes for development of a harborage site are, how did the bacteria get into the ready-to-eat production area? That's number one. And number two is, once it's in that area, how did it take hold? And so root causes can be traffic patterns. They can be equipment design. They can be a lack of equipment onboarding procedures, cracks and holes in floors and walls, and damaged concrete. Those are all examples of how bacteria can migrate in, translocate from, just as John said, a zone 4 to a zone 3, and then once it's in a zone 3, perhaps to a zone 2 and to a zone 1. And that translocation, if it stays in a area, that area can be a harborage site. Next, please. Okay, so what happened in case number 2? First of all, there was a buyer, and the buyer purchased a film equipment from a seller, and then they installed the equipment in the production environment. About 3 to 6 months after the equipment was installed, the USDA came and performed a comprehensive food safety assessment, which took about 6 weeks. And within that food safety assessment, they tested product, equipment, and the environment for listeria. The results of those tests were one finished product and one environmental test site, or one environmental site tested positive for LM. The USDA issued a notice of intended enforcement, and the plant did not respond in an adequate manner, and the USDA came back about a month later and issued them a suspension. So they suspended operations until the plant could demonstrate that they had control over this listeria issue. So once the notice of suspension was given, the plant hosted an investigation, and they tested 53 samples, and 3 were confirmed for LM, 2 in the equipment, and 1 in the product that was used for that equipment. They determined that the equipment was a harborage site, and then they did research into the seller, and they found that the seller had a recall for LM. So then they sued. Next slide, please. What the plant did is, when they got the equipment, they purchased it. It came on a pallet, sat on the loading docks, sat in storage for a while. Before production, the plant warehouse individuals cleaned the film equipment, and then it was installed into production. Next slide, please. So what the things that the buyer did not do was, they didn't have an equipment onboarding procedure. They didn't check to see if the seller had a recall in the near past. They didn't swab the equipment prior to it entering into the building. They didn't have an intensified cleaning and sanitation procedure. They didn't perform sanitation verification swabbing after the warehouse personnel cleaned the equipment, and they didn't do a dry run once it was installed in the production area and prior to use. Next slide, please. So the legal arguments for the buyer, which the prosecution, proved that the equipment was a harborage site. And the seller rebutted that the lack of buyer's food safety practices were the true root cause. Had there been no root cause, there wouldn't have been a harborage, was the argument that the seller made. Next slide, please. So the conclusions of the lawsuit was that the case settled. The settlement amount was dramatically reduced, did not nearly cover the cost of the expenses due to the USDA suspension, simply because the buyer proved negligent, or the seller proved the buyer negligent. Next slide, please. And with that, we'll move on and entertain questions and comments in our panel discussion. Thank you so much.
Thank you, Virginia. Again. It's my pleasure to introduce our final speaker, but I would like to remind the audience to, if you have questions, please feel free to submit them to the question box. But our final speaker is Mr. Jeremy Travis. Jeremy Travis joined Hilmar Cheese Company in 1998. He's currently serving as the Vice President of Quality and Technical Services and responsible for all aspects of product research, technical services, food safety, and quality assurance. During his tenure at Hilmar Cheese Company, Jeremy has served in a string of VP roles, including quality, manufacturing, procurement, food safety, process technology, and asset and project management. Basically, he's done it all. Jeremy holds a bachelor's degree in dairy sciences, concentrated in technology from California Polytechnic State University, San Luis Obispo, and a Master of Business Administration concentration in operations management from Cal State as well at St. Louis. So over to you, Jeremy.
All righty, thank you, Haley, and thank you for the opportunity to present. If you can go to the next slide, please. Thank you. And this is like everyone else. These are my views and experiences we'll share here. And here's a list of organizations that I'm interrelated with. But I am an employee of Hilmar Cheese and Ingredients. Next slide. I kind of took this from multiple definitions of out of the box, whether it be experience outside of the building, or just things that are out of the box, or things I don't commonly see within industry. So, you know, I think Haley was able to give enough of the background and association. So we'll move past this, but next slide, please. Yeah, so potential problems from far to near the facilities. And I'll elaborate on a few of these as I speak. Activity outside of work and personal clothing, the parking lot, which has come up from others, and Joe, personnel traffic paths outside the buildings, visitors and contractors, again mentioned, parts and material storage, elaborate a bit on that, roofs and walls, and building penetrations and expansion joints. The next slide, please. Activity outside of work and personal clothing. I remember when I was a plant manager over 15 years ago, running into an employee in Home Depot, seen him wearing a company jacket, asked what the person was up to, and heard something I didn't want to hear. He was building a chicken coop. And since we had captive uniform, and we have moved toward captive uniforms and boots. So that what people do outside of work and their personal clothing definitely has to be kept outside of the facility. Parking lot, consider routine cleaning and surveillance, not just that's where the cars go. Personnel traffic paths, defining walk paths separate from powered equipment. I believe a few others had covered similar things along this line. It's not just for personnel, but reduces, and safety, but reduces expressions from unsanitary areas. Uniform name tags are color coded by department. For example, a milk department, which is raw, would say have an orange name tag as a quick identifier. Cheese plants, which are more of a wet process, daily cycling for sanitation, a different color. Powder, which is, and utility. So you wouldn't see any of those four groups, for example, in another. Department specific card readers in modern times, limited movement so that folks, we don't rely on decision, that we physically made it not possible for people to cross raw, ready to eat, wet, dry, outside, inside environments where they don't need to be. And then single entrances to each department, kind of picking up where Joe touched on shoes, captive shoes, hand wash, where they come through one versus many entrances. Some comments around visitors and contractors. ISN is an example of a third-party verification and compliance service, a membership requirement for us to do business. Safety and food safety compliance in addition to standard liability coverage. So you get a kind of a broad view of how responsible folks you're inviting to your facility are, and food safety, and just overall liability. Food safety and sanitation kickoff meetings, that's a very standard. Make sure that everybody's on the same page. Anytime, I believe Virginia touched on this, where you have invasive construction or repair work with third party, not just physically blocking, but make sure everybody's in the same direction. And then just designated lead to oversee enhancement, the type of their plan for hygiene controls and during work. So not just agree, but also to monitor for effectiveness. I think Joe touched on this as well. Break areas outside of the food processing areas. So folks need to take their breaks, make sure that those who are outside and inside don't find themselves sharing those common areas. Next slide, please. Parts and material movement, proximity, I should say for spare parts and equipment. If there's a common storage that's maybe far and away from things, that's maximizing expressions and movements. So sometimes staging. All tools sanitized into high care areas, and serious consideration of captive tools when it could be reasoned. And then whether it be in from a wet to a dry room, or outside to inside airlock transition room, so that there's not the possibility of two doors open, drafting unfiltered, uncontrolled air across a processing facility. Switching into roofs and walls, actually capturing those in the master sanitation schedule. considering service contracts in place for annual inspections and assured immediate response when things breach, obviously unplanned. We can have someone there in 2-week answer is never going to be good. So service contracts tend to shrink that time up. External stairwells to ensure no return to building after on roof. So if someone does end up needing to leave the building, get to the roof, that there's no at least eliminated the reliance on coming back through the facility. Building penetrations and expansion joints, expecting for integrity or sealed joints and seams. Materials expand, contract, and wear, so making sure that that's been addressed. And the PM program for all wall and roof penetrations, including that with just like you would a processing equipment. Next slide, please. And maybe just some other more, this is the out of the box atypical activity, but and it's not just micro in this, but maintaining a library of all non-detectable materials, gaskets, packaging, etc. So something's found, you can say it is or isn't in the system, or have a quick guide that allows you to get to the bottom of that. Use of simpler genetic-based methods such as MLSTs, multi-locus sequence typing, to understand the microbes are identified, should one breach a facility, and understand movement instead of being generic to a category microbe. Maybe realize you have 3 different, I'll just use the word strains. I'm not a microbiologist, but allows you to solve the problem with a little more detail, kind of get the bang for the buck on that investigation. Building asset management program in annual reviews as a mechanism to ensure conditions of building support sanitary design as well as proper maintenance, not just rely on the original project, the original install, but just stay on that as things evolve. An investment portfolio for the company includes one dedicated to food safety and quality assurance, not competing for other priorities, but to make sure that's in place. Dedicated process engineers to cleaning systems, that tends not to be common. Instead of as things pop up, and again, assigned to an engineer or a third party, a dedicated process engineer has proven valuable. And use of third party engineering firms to assist with building strategy for raw ready to eat, wet, dry, and risk reduction opportunities. It's never accepting and always looking for opportunities to break the link between these risks and the food. And another kind of, I think the world has learned the importance of this, but reporting of food safety is through the top management, same as all other business results. So that was some of the out of the box thinking. That might be the last slide.